Good morning, Veritas. This is the lesson for Thursday, April, 9th, 2020. I hope everybody's staying healthy and working hard. Let me know if you have any questions, but we're going to get right into yesterday's problems first. So these are the ones we're going to solve right now. These were from yesterday, from Wednesday, April 8th. We're going to go over these momentarily, so pause here if you haven't done them yet, and you can do them on your own and then watch how to solve them. And these are the ones that we'll be doing tomorrow. If you would like, or I would like you to try these today. After we go over these ones, I want you to try these ones on your own. So pause here and write them down, and they are actually in your assignments for tomorrow if you want to look there. All right, so I'll move that one. We'll go over those ones tomorrow, and we will start with the one that says Wednesday from yesterday. Okay, so get yourself a whole blank piece of paper. We're going to show our work here for number one. Make sure you have plenty of room. I use a couple of different colored pens or a couple of different colored pencils to help me as I go through this. Okay, number one says Johanna spent 3/8 of an hour playing with her dolls. Then she spent 7/12 of an hour drawing. So part A says, which activity did she spend more time doing? And part B says, how much longer did she spend on your answer to part A than the other activity? Okay, so which activity? They're both talking about these two different activities. So she spent 3/8 of an hour playing with her dolls. I'll just circle dolls. 3/8 of an hour, dolls. So I'm going to write that over here. Dolls, 3/8 of an hour. Then she spent 7/12 of an hour drawing. So drawing, 7/12 of an hour. So we have the same unit. We're talking about a fraction of an hour and a fraction of an hour. So did she spend more time doing which one? Dolls or drawing? Okay. Which activity did she spend more time doing? So we're not adding these or subtracting them or anything like that for this problem. We're just saying which one is bigger. Which one did she spend more time doing? Is 3/8 more when she played with dolls, or is 7/12 more when she did her drawing? Okay, so here's how I solved this one. We could make them into the same denominator. We could turn these denominators into 24 and see which one is bigger. That's one strategy we could use. So 3/8 is how many 24ths? And 7/12 is how many 24ths? Because if we turn them into the same denominator, that's the same number of pieces in the whole. If they have the same number of pieces, then whatever the bigger numerator is going to be the bigger fraction. Okay, so we're going to multiply these fractions both times 1. We're going to multiply them times a fraction that's equivalent to 1. So 8 times 3 gets us to 24, so we have to multiply the numerator here times 3 also. That way we're multiplying times 3 over 3, or 3/3, and that equals 1. So we can multiply it times 1, and it's not really changing. It's just making an equivalent fraction to 3/8. That way it has a denominator of 24. So 8 times 3 was 24. 3 times 3 is 9/24. So 3/8, 9/24 are equivalent. So we can use this instead of this to see which one's bigger. 12 times 2 got us to 24. So we need to multiply this times the same number. 7 times 2. Because 2 halves, if we multiply that times 2 over 2, same thing as multiplying it times 1. And again, we're not really changing it. We're just making it so that the denominator can be the same as the other denominator. 12 times 2 was 24, so 7 times 2 is 14. Now, if 3/8 equals 9/24 and 7/12 equals 14/24, then 7/12 is bigger. Because 14 out of 24 is more than 9 out of 24. So we know that 7/12, since these are equal, 7/12 is bigger than 3/8. Okay, so she spent more time drawing because 7/12 is more than 3/8. Okay, so which activity did she spend more time doing? The answer is drawing. Okay, here's another way I want to show you for how you can solve this problem. Okay, you could have turned the numerators into the same numerator. That's another strategy, but I want you to look at it this way. We talked about this a little yesterday. So if we have 3/8, okay, 1/2 of eighths 2 times 4 gets us to 8. So 1 times the same number, 1 times 4 is 4/8. So if 4/8 is equal to half, 3/8 is less than half. Okay? 4/8 is half. So if you have 3/8, then you have less than half, because you would need 4/8 to be half. So this is less than half. Now let's look at 7/12. 1/2 would be how many twelfths? 2 times 6 got us to 12. So we're going to multiply the numerator times 6. 1 times 6 is 6/12. So if 6/12 is a half, 7/12 is more than half. Okay? 3/8 is less than half because 4/8 would be half, so 3 is less. 6/12 would be half, so 7/12 is more than half. So if we know that this one's less than half and this one's more than half, we know that the one that's more than half is bigger. Okay? So that's another strategy. They call that finding benchmarks. Comparing this to 1/2 and comparing this to 1/2. If one of them's less and one of them's more, then you know that the one that's more is bigger than the one that's less. So drawing is our answer for part A. Thank you for paying close attention to that one. Okay, so that was part A. Now we got plenty of space here for part B. It says, how much longer did she spend on your answer to part A? So drawing, which was 7/12 of an hour. How much longer did she spend on my answer, which was drawing, than the other activity, which is playing with her dolls? So this is how long she spent drawing. How much longer is this than 3/8? So we know that this one is bigger. So we're going to find the difference between these two fractions. We're going to take the bigger one on top, because we just said it was bigger, and we're going to subtract the smaller one to find out how much longer this one was than this one. So we are subtracting. So check what operation you did. This is a subtraction problem. But 7/12 has to be on top, because when we subtract, the bigger number has to be on top, and you subtract the smaller number from that. All right? So we're going to turn these both into 24ths. In order to subtract, they have to have the same denominator. So 12 times 2 was 24. So we're going to do 7 times 2 is 14 24ths. And all we did, like we've been talking about, we multiplied it by 2 halves, which is the same thing as multiplying it times 1. So it didn't really change. It's just an equivalent fraction so that it has a 24 as its denominator. And we're going to do the same thing here. We're going to multiply it times a fraction that's equivalent to 1, and that's going to get us to 24ths, so then we can subtract. So 8 times 3 was 24, is 24, so we're going to multiply this times 3. That way we did it times 3/3, which is equivalent, again, to 1. So we're not really changing it. The value is the same. We're multiplying it times 1. We're just making it so that the denominators can be the same. So 8 times 3 was 24. Now 3 times 3 is 9 24ths. So we have, that was what we got earlier, right? So we have 14 24ths minus 9 24ths. Since they are already 24ths, the denominators are the same, then they stay the same. That's just telling you how many pieces are in each whole. Okay, 14 minus 9 is 5. So we have 5 24ths. Now let me just check. Can I simplify this? Can I divide those both by 5? Nope. I know 6 gets to here, but you can't divide this by 6. I know 3 gets to there, but you can't divide that by 3. 8, 4, 6, you cannot divide either of these. You can't divide them both by 2. Can't divide them both by 3. There's nothing we can divide these all by. So that is the answer to this problem. 5 24ths. She spent 5 24ths of an hour longer on her drawing than she did playing with dolls. Okay? If you got those, give yourself some snaps. Nice work. If you didn't, these are word problems. We have to spend a little bit more time really carefully reading them and making sure that the operation you chose to do was the right one. I can guarantee you that some kids guessed and they added these, or they subtracted them, or they multiplied them. They just guessed. This one is just asking you which one is bigger. Which one did she spend more time doing? So you have to really, really read those word problems carefully because if not, they're gonna try to trick you a little bit. All right. So now I'm gonna flip over to the back. I started some models just to make this a little faster. We're already at 10 minutes in the video. So here's number 2. It says write 19/6 as a mixed number. So this is an improper fraction because the numerator is 19 and that's bigger than the denominator, which is 6. So 6/6 would be 1. So 19/6 is a lot more than 1. So we're going to write it as a mixed number, meaning that there's a whole number and a fraction. They are kind of mixed together. Okay, because this is more than 1, so we need to write it with its whole number of how many ones and then what fraction is left over. So 19/6. I'm going to write this here. 19/6. Now I'm going to show you in a model. So I cut each of these holes into sixths. 1, 2, 3, 4, 5, 6. They all have 6 equal sized pieces in each hole. And the holes are supposed to be exactly the same size. They're very close. Okay? So if this hole is 6/6, the whole thing, there's 6 of them. And then this hole would be 6/6. So far we have 1 hole and we have 2 holes. And we have 6 plus 6 are 12/6. We're going to 19. So 13, 14, 15, 16, 17, 18. So we can color in this hole because there's 18/6, which is 3 holes. So 6/6, 6/6, 6/6. That makes 6, 12, 18/6. We're going to 19/6. So we still need 1 more from this next whole number. And there's 1/6. So altogether, 6, 12, 18, 19/6. As a mixed number, there are 3 holes, and then there is 1 more sixth left. So the answer is 3 1/6 as a mixed number. Okay? The way that I learned it when I was a kid, 19/6 is division. That is 19 divided by 6. Okay? So if we did 19 divided by 6, if we had 19 pencils and we were breaking them into 6 equal groups, how many could go into each group? So 6 times what gets you closest to this number of 19, and it's 3. So 3 times 6 is 18. That means there would be 1 left. And we've been talking about how as a fraction, so that's 3 as the whole number, just like we got when we did this. The numerator is the remainder here, the number that was left over after you subtracted, becomes the numerator, 1. And the divisor, the number you divided by, becomes the denominator, 6. We get 3 1/6, just like when we did here. Okay, so 6 goes into 19 3 times without going over. 6 times 3 is 18, so there's 1 more to get to 19, and the denominator stays the same. So there's a few different ways to get to 3 1/6. All right. This is going to be easy when it's a number like 3, like 19/6, but what if we had 254/6? We're going to have to draw tons and tons and tons of models. So at some point, once we understand, okay, this works this way, we can just divide these and get the right answer, then we need to really move into this division. That's why it's so important for us to practice our long division algorithm so that we can do it and we can do it quickly. That way we don't spend a really long time doing this. But I'm happy to do it this way to show you why it works, but then we got to get to the point where we are able to use one of these 2 strategies to get the answer. Okay, so 3 1/6 is the answer to that one. Good job if you got that right. And last one, number 3, write 2 3/5 as an improper fraction. Okay, so this is a mixed number, and we're writing it as an improper fraction, like this one. So mixed number, improper fraction. Improper fraction is greater than 1. Mixed number has a mix of a whole number plus the fraction that's left. Okay, so we're going to write 2 3/5. Let me write that over here. As an improper fraction, which means it is greater than 1. Okay, so here, I drew 3 holes because we have 2, and then we're going to have some more of the third hole. So we need actually 3 holes here. Okay, so these are all cut into fifths because that's our denominator here. So there's 1, 2, 3, 4, 5 equal pieces in each hole. Okay? So we're trying to figure out how many fifths is that all together. So let's count the fifths in 2 holes. There's 5 here. There's 5 more here. So far we have 5, 10 fifths. It says we need 2 and 3 fifths. So let's color in 3 fifths of this last one. There's 3 fifths. So we have 5 plus 5 is 10, 11, 12, 13 fifths all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and each of them is a fifth of the whole. So 13 fifths is how to write this as an improper fraction where the numerator is greater than the denominator. Okay, so 13 fifths is our answer. If you count up all the fifths in 2 and 3 fifths, you have 5, 10, and 13 of those fifths. Okay, the shortcut I learned when I was a kid, they didn't teach me why, they didn't show me models how to do it, they just said, hey, this is what you do. You multiply 5 times 2, because each of these 2 holes has 5 pieces. So 5 times 2 is 10, just like when we counted these 2 pieces, there were 10 fifths, right? But what you can do here is just 5 times 2 plus the 3. That'll give us our numerator. So 5 times 2 is 10, plus 3 is 13, and our denominator stays the same. It's fifths. Okay, so you basically are taking the denominator times the whole number. 5 times 2 is 10, meaning that there are 10 of those fifths here. Plus the 3 more for here is 11, 12, 13 fifths. So this is a way you can do it. Be a little bit faster, but the reason why that works is because each of these 2 holes has fifths in them. So you can just do 2 times 5, which would give you these 2 holes, which are 10, plus these 3 more make 13. So that's the answer for today. Really good job. Send me your work. I would like to check it out on Google Classroom. And try these ones now. Whoop. Try these 3 problems for Thursday, April 9th, 2020. And we will go over these tomorrow on Friday. All right. Good luck. Thanks for watching. Hope everybody has a great day. See ya.